this is a phrase that I use all the time that I got from Gilbert Ryle in a late paper by Gilbert Ryle, where he's trying to explain the relationship between thinking and talking. And he's basically saying, well, thinking isn't just talking to yourself, but it's not something else in addition to talking to yourself. Right? So he's like, it's not like you want to get between one thing being nothing but another thing, and one thing being something else in addition to the other things. Right? So when you have a synergy, there aren't multiple entities that is the synergy. There's just the collecting components that form a structure that that alters the behavior of the components in the collection. And actually, I think that this way that Ryle puts it is kind of how we want to explain almost everything in the cognitive sciences. Right? I mean, thinking isn't something else besides activity of your biological body, but it's not just that, right? So you want to again get between thinking being nothing but brain activity and thinking being something else in addition to brain activity.
Anthony Chemero is a professor of philosophy and psychology at the University of Cincinnati. He does both empirical and philosophical work, and he's interested in nonlinear dynamical systems modeling, ecological psychology, enactivism, embodiment, social cognition, complex systems, and phenomenology. He's written extensively on radical embodied cognitive science, but in the course of this conversation, we'll come to learn what radical might actually mean here. Here we talk about ecological psychology, nonlinear dynamical systems theory, embodiment, social cognition, a bit about mirror touch synesthesia, and some base problems in cognitive science and the philosophy of science. Here is my conversation with Anthony Chemero. Just to start off with, representationalism in cognitive science. I'm confused here. So where are representations still useful, and what is the argument for not using representations?
So I wrote this book, right, where I argued that you could do cognitive science without representations, and it's called Radical Embodied Cognitive Science. And Rick Dale wrote the best review of the book ever, in which he said, the dirty secret of this book is that it's not very radical, because I don't argue against the explanatory value of representations across the board in the cognitive sciences. I try to demonstrate that it's possible to do good scientific research, especially on basic perception action, that does not invoke the term. So, I mean, if you were going to give a theory of memory, I can't imagine how it would work any way other than saying that you have a representation of some past event. So representations are explanatorily useful some places in cognitive science, but not all places in cognitive science. And I guess that what I'm suggesting is that the default assumption shouldn't be that if you can do something, you do it in virtue of building an internal model of the environment and manipulating that model. I mean, that's a substantive empirical claim, and some people seem to think it's kind of the definition of cognition.
Right. As sort of like a methodological point, do you approach it as if we can build more elementary models of any cognitive properties and then scale them without invoking representations, then that's a better strategy than invoking representations for more complex things?
This is making a cognitive science point about how one ought to do cognitive science, but for me, it kind of starts with a background in philosophy. And one of the things you realize when you look at basically philosophy since Galileo and Descartes is that once you bring representations into the game, that is, once you think the job of my experience is to rebuild the world the job of my thinking is to rebuild the world inside of me, you've swallowed a whole bunch of difficult philosophical problems. And what I think and what I argue in the book is that you can replace those with a bunch of much easier ontological problems about the nature of information and the nature of the environment. So the real motivation has been to kind of change the way the kind of general philosophical picture of what the mind is, not a little cabinet inside of you or floating above you somewhere, but instead it's kind of interdependent with and partly consisting of things outside of you, especially tools and other people.
Right. Okay, so just for the audience, do you mind defining ecological psychology just a little bit further?
I do not mind at all. So the ecological approach stems from work by James and Eleanor Gibson, starting in the 1950s. And there's the kind of Old Testament, James Gibson's 1966 book on the senses, and then there's the 1979 book, which is the New Testament. My students and I make lots of jokes about stupid things like this, which is the ecological approach to visual perception. And in both of these works, Gibson, who is ultimately trying to kind of make a science out of late William James' understanding of perception, argues that in order to study the world, our perception of the world, you have to start with the world, right? He said, the thing that we do in the cognitive sciences, we assume that the world has very little structure and we have to do a bunch of mental work in order to perceive the world as it is. But in fact, he argues that there is tons of information available in the environment that we can use to kind of grab onto the environment. So especially for an animal that moves, because like every time you move your eyes, your head, you're basically creating a flow that carries information about the things around you. So what Gibson says is that it's ecological in that you start your explanation of perception in the environment with the information available for perception. And only once you've really understood the information available for perception would it make much sense to start speculating on the function of neural elements or things like that.
How does Gibson differ from James and Merleau-Ponty?
So James, and this is especially his later work, what's often called radical empiricism, is trying to kind of make sense of perception. And he says this, it's a beautiful line. He says, all of the problems in the philosophy of perception are because we assume that there are two things, one inside and one outside, when there is in fact one thing, right? So James is trying to explain perceiving the world as being in and with the world, being connected to it, not building a representation of it in your head. And Merleau-Ponty comes from a totally different source, late work of Husserl primarily, and Gestalt psychology, and tries to make sense of perception and our experience of the world and what we are as people in terms of our readiness to engage with the environment. So these are kind of two very different branches of philosophy, pragmatism and phenomenology, but they kind of converge in a lot of ways. And one of the places they converge is in the work of Gibson. Gibson was explicitly, in his autobiography, talks about being a radical empiricist like William James, like E.B. Holt, his advisor. But at the same time, in the late 1960s and early 1970s, he and his PhD students did an extended, very careful reading of Merleau-Ponty's phenomenology of perception. And Bill Mace, psychologist who's retired now, went to the Gibson archives at Cornell and found Gibson's lecture notes on Merleau-Ponty. And among them are detailed descriptions of what Merleau-Ponty says, but then it breaks off for a while where Gibson will start saying, this makes me think this about how we see one thing occluding another, behind another. And he writes several paragraphs that aren't in Merleau-Ponty, but end up in his New Testament, the ecological approach to visual perception.
Right. Gibson doesn't at all read like science.
Yeah, I mean, so there are certain thinkers in the 20th century who thought of themselves as writing for posterity, right? And then, like, Gilbert Ryle is a good example. If you read The Concept of Mind, he cites essentially one or two other people in the whole of the book. And Gibson, I think, thought of himself as writing for posterity, right? He thought so. was not engaging with the detailed scientific findings of his time, especially in his later book. And if you pick up that book, it's called The Ecological Approach to Visual Perception, and it was actually marketed as a textbook for teaching psychology, psychology of perception courses. But the first half of it is just a description of what the world is, right? A description of what the world is, so that it makes sense that meanings might be in the world and not created by your brain. So ontology, effectively. So like the first 8 chapters are ontology.
So, how does the ecological approach pair with phenomenology today? That's a tough question.
That's a tough question, and there's a lot of disagreement on it. So people who are serious ecological psychologists don't want to hear about Merleau-Ponty, but there's a kind of new generation of philosophers who think that mostly influenced by Hubert Dreyfus, but also by Varela, Thompson, and Roche, who think that combining these ideas from French and German philosophy of the 20th century with the cognitive sciences is a way to make progress. And the way to make progress, they think, is to say, okay, what does Merleau-Ponty say about perceiving other people? Let's try to make that into science. And the easiest avenue to make that into science is James Gibson's ecological approach, right? Because Gibson was a scientist despite his last book, and was always trying to basically make difficult philosophical questions into tractable experiments that one can do.
Right. So, are you committed to any one of those views of doing philosophy?
So I guess this might be like a personal history moment. When I was in graduate school, I was kind of simultaneously studying dynamical explanation and robotics, and then we had a kind of secret Heidegger reading group, which morphed into a Merleau-Ponty reading group. And one of the things that I was trying to do at a certain point is, how can this stuff, this weird German philosophy and French philosophy, interact with the cognitive sciences? And that's when I came across James Gibson's work and the ecological approach. And what was interesting to me is that Gibson's work has asks lots of the same questions and proposes similar answers to that of Merleau-Ponty in the phenomenology of perception. So this was an aha moment for me. We can be influenced by phenomenology and still do cognitive science if we start with this approach.
Did you ever find a way to apply Heidegger specifically?
Heidegger. So I tried for years to find a way to do an experiment that would be related to what Heidegger called the transition from ready to hand to present at hand or unready to hand. And so Heidegger's point is that basically when you interact with things in the environment, they feel like they're part of you. You don't perceive them consciously, you don't think about them, you just use them to go about your task. And with a former student, Dobry Dotov, who's now at McMaster University, we tried to do a series of experiments to try to make sense of that transition. And finally, he found one that worked. So we had participants play a very simple video game using a mouse to control a pointer on a monitor and their job was to corral a recalcitrant ball into the center of the monitor. And what we did is during the course of the experiment, we disrupted the connection between the movements on the mouse and the movement of the thing they were controlling on the monitor. And in doing this, we were taking very detailed motion capture recordings of their hands, and we found a kind of transition in the character of their behavior between when things were working well, when they weren't, which aligns with transitions one sees when you look at the differences between healthy hearts, for example, and unhealthy hearts, right? So the pattern of activity becomes unhealthy when we disrupt the connection. So that was what we thought was, and I actually still think was a pretty good demonstration that Heidegger was onto something in his claims, which, you know, the claims about how we experience the world. So they could be psychological claims. And I think what we demonstrated is that there's something going on in and around this transition that he talks about that has to do with kind of functioning well with while using a tool and breaking your connection to the tool. So the tool becomes the thing that you're dealing with, not the thing that you're using to deal with something else.
That's remarkable. That's the only empirical application of Heidegger I've ever heard of. I don't know if there
We did a follow up. We did a follow up that similar results. For Heidegger, he talks about there's what's ready to hand and what's present at hand. The ready to hand are the things that you are fluidly interacting with. The things that are present at hand, you are staring at, trying to understand of them, thinking about them. And he has multiple different definitions, what he calls unready to hand. This is the English translation, unready to hand, which is kind of a waypoint in between fluidly engaging with your environment and staring at things dumbly. And he defines it in multiple different ways. And we think that the first experiment that I just described gets us to the transition from ready to unready to hand. What we were interested in, what Heidegger spends most of his time talking about, is going from ready to hand to present at hand. That is, going from treating something as a part of your body that you're controlling fluidly to having it be a thing in the environment that you have to think about and deal with. So a second set of experiments, we focused on that transition. And basically what we did is we made it so that the disruption in the movement of the mouse controlling the object on the monitor was more severe, so that people had a harder time just working through it. And in fact, in the first experiment, most of the participants didn't report noticing that the mouse stopped working, right? Because it was a 60-second trial and only 6 seconds of braking. I mean, they didn't notice it. But in the second experiment, we made it so that there was no way they could miss the fact that their thing they were controlling wasn't going where they wanted it to go. And then we saw other transitions, especially in like heart rate variability, which is a sign of stress. So we predicted that having the tool you're using break would be a stressful thing. And so that's one of the examples. So one of the ways we said this is actually present. And we also found differences in the movement that were similar to the first experiment, from ready to unready to hand.
just as a aside, we don't have to go here if you don't want to, but I gotta ask you about Heidegger. So Heidegger obviously has this political background. He was a horrible Nazi. And in political philosophy, there's been work done that illustrates that that's part of his political thought. And I'm not committing to the idea of holding thinkers in their historical context, but do you think there's a link between his political philosophy and his phenomenal work?
So, I mean, there is basically like a conservative reading of Heidegger and an emancipatory reading of Heidegger. And this, if this gets too far afield, stop me. But, you know, there's a kind of the end of Division 1 of Heidegger's Being and Time. He is writing about the relationship between individuals and the culture in which they live. And what he's basically arguing is that I have my experience because I participate in an us, and I have the kind of experience that we have, right? And so the emancipatory understanding of Heidegger is that, wow, that we share experiences with, that is kind of our people, can be as big as we want it to be. But you could also read it so that we are the Aryans. And I think that's what Heidegger chooses to do. But I think that's optional. Heidegger himself, as you point out, was a terrible, terrible man in every way. But, you know, I think that there is a potential, at least, to read his kind of social constitution of individual experience as being a positive political idea. And again, what we need to do in order to make it that is to not think in terms of parochiality or small groups of people. Like, you know, humans are us, right? So I have the kinds of experience I have because of the culture of humans that we live in, right? So again, you can read it, and this is how obviously I prefer to read it. But again, it's really a matter of who you include in us, right? And if you want to read that narrowly, you end up saying things like Heidegger said, like that Jews didn't have worlds, didn't experience the world because they weren't part of the us. And that's a shockingly bad thing for him to have said, because he said of non-human animals that they have an impoverished world. Their world's poor, he said. So, he's arguing that Jews are less like us than, lizards, right? And again, terrible, terrible thing to say. Terrible thing to say, and just exactly the wrong way, I would argue, to interpret his view of, again, this kind of me being me because I'm part of us, understanding of what it is to have experience.
Right. Like he'll say things like we need a political culture that establishes values and that affirms life, and it's just a matter of where you want to put emphasis on that political culture. You can take an interpretive choice of whether you want to take a narrow view of that, and I think Heidegger does take a narrow view of that, like you mentioned, or you can take a more liberationist view.
I mean, I think so. I've been thinking a lot about this. I've been writing a new book on social cognition, and I mean, think about, you're much closer to being a teenager than I am, but think about when you were a teenager and how you experienced the world in terms of your like little posse of close friends, right? So I think this way in which we are necessarily of and with other people can be both good and bad, right? That is, this, like, me and my clique could do this at this party, or me and my clique could do that at that party, or that social event of whatever kind, ends up being very exclusionary. And that one of the things about growing out of being a teenager is you stop seeing the world in terms of you and your 5 friends. But yeah, so I mean, I think what Heidegger argued for as the kind of correct interpretation of his view, where the us is as narrow as you want it to be, is actually true of the experience of people at certain points in their lives. And maturity would suggest that you want to include more of humanity in us than you have already.
Right. So it's a developmental component that's missing.
There's a developmental component. Yeah, I mean, I think, and again, not all teenagers are like this. I certainly was like this as a teenager. Like, I had my friends, we had our things that we liked, and I would see the world in terms of, what we could do. And that would be the kind of center of my experiences, what we could do. But again, I think as I hope that for most of us, as we get more mature, we don't see the world in such cliquish terms. And I think, unfortunately, right now in the US, people do see the world in these cliquish terms. So you see people saying things that they couldn't possibly believe about political figures, not in order to be taken seriously as saying something true, but to identify their clan. So, I mean, you can see this. I guess there's a constant danger if Heidegger is right about the fact that what an individual is part of a collective, and that collective determines what the individual can be like. And I think he is correct about that. Then we have to be especially careful, right? I mean, it shows the dangers of our social interaction. I remember when I was first starting to write about this, I was talking about, being with others, and it sounded all kind of hippie and kumbaya, like, you and your friends form like a unit that has all the same properties of an individual, just as shorter lived, and we're all kind of together in one thing for certain purposes. People started saying, oh, Tony's like saying all these weird hippie things, like, everything is groovy. But in fact, it can be very negative when people identify with a clan more than anything else. and part of being in that clan is excluding other clans. So and the kind of maturity that's required in order to kind of not think this way is beyond a lot of people. I worry.
Yeah, I mean, one of the problems is also if you have a thinker like Heidegger or Nietzsche, more pragmatic, or Nietzsche as a better case, that is so appealing and writes in such a friendly way with so much rhetoric. They appeal to people in and outside of the academy. So it appeals to people when they want to affirm their spiritual beliefs or their personal beliefs. And when you're taking it that way, there isn't really that much careful and consideration paid to interpretive moves. And
I mean, if you think about what even professional philosophers do with like the history of philosophy, they're mining it for ideas that they can use to confirm what they think is true now. Right? And Heidegger is especially a case of this. Wittgenstein is another, but they're basically, if you're a Heidegger scholar, your interpretation of what Heidegger thought is always what you think is true. And the same is Wittgenstein, right? Wittgenstein scholars, like, here's what I think Wittgenstein was up to. And by the way, that's true. So that's an exception, I guess, to this, like mining of work for just little tidbits that you can use in order to make the point you want to make. And what my point in bringing this up is I think that even mature professional academics are guilty of this, of having an agenda when they read work from the past.
okay, so coming back to phenomenology and looking or operationalizing phenomenology, looking at the possible empirical applications, do you think this is sort of a general approach that can develop and be applied to a lot of phenomenological approaches, or it's kind of just pick and take?
So science is hard, right? It's hard to take a complicated idea and make it into something that you can kind of sort of find out about in a laboratory setting. So I think that there aren't many good cases of this. One of the things, as I said, I've been writing about social cognition, is I've been very interested in work in social cognitive science that strikes me as confirming some of the less well-known ideas in Merleau-Ponty's later work. So, for example, he steals this term from Husserl, which he calls the ineinander, which Husserl, which German literally means in one another. And Merleau-Ponty basically runs with this and says, look, the self in the world, self is in the world is in the self is in the other is in the self. There's kind of one entity here. And my sense is that work in certain strands of psychology, social psychology, social cognition, for example, work by Alexandra Paxton and Rick Dale and Drew Abney and Mike Richardson, strikes me as demonstrating something like what Merleau-Ponty was talking about. Because from the point of view of, again, maybe this is, again, too far afield, but in these, like, people use nonlinear dynamical methods to do these experiments. And those methods have a history of being applied to distinguish between healthy and unhealthy things. So what Alex and Rick and Mike find when they do these studies is that when people are smoothly socially interacting, they give off the same kind of dynamic signature as a healthy organ does. And Alex and Rick and Chris Kello as well, and Drew Abney, I think, are the authors of this paper I'm talking about, demonstrate that you can actually read off of these complex dynamical systems measures whether people who are having a conversation are agreeing or disagreeing. Right? That is, there's more of this signal of health when they are having a pleasant, fruitful conversation than when they are not.
Okay, so in the 20th century, you have ecological approaches, and then you have dynamical systems theory, and then they will get entangled somehow. How does that play out?
So the story I'm going to tell is directly from Michael Turvey, who's one of the people who kind of first brought dynamical systems to psychology. Um, so he was working at University of Connecticut, and he gets contacted by Peter Kugler, who is an engineer, who called him and said, "I know how to do this." And the way Mike puts it is that Peter Kugler came and just took over the lab. And Peter was working in this far from equilibrium dynamics systems way of thinking. And what Peter and Mike and Scott Kelso together did is they brought this into making sense of human behavior, not just say phase transitions in matter or things like that. We can actually understand human behavior in terms of humans are things that are far from equilibrium, so they have self-organizational properties, and self-organization has specific consequences that we can look for and measure. So, if you ask Mike, he says Peter Kugler just took over, and that's where the dynamical approach in psychology comes from. Um, um, and Scott Kelso also was in Connecticut at the time. The three of them worked together. Sorry, I should point out that Michael Turvey in 1980 was one of the few people who continued to do James Gibson style psychology after Gibson himself died. So University of Connecticut was and still kind of is a world center for the ecological approach. And what Kugler, Kelso, and Turvey, Peter, Scott, Mike, argued is that understanding human behavior as self-organizing is a way to make sense of this enigmatic thing that Gibson says in his last book, which he says, behavior is regular, but isn't regulated. That is, there's not like a homunculus driving the ship. So behavior is regular, but not regulated. The question is how that could be. And Kugler, Kelso, and Turvey are trying to answer that question by saying behavior is regular without being regulated, without a homunculus, because it's self-organized. So it's a property of structures that are far from thermodynamic equilibrium, that use forces to generate flows. And it's a very complicated story, but the hope was to answer this question from Gibson about the nature of behavioral control, and giving a non-homuncular understanding of that.
Right. So then what happens to ecological psychology afterwards? Because it seems like they're quite separate. They're quite different in the way that.
Well, so I think what you see is a lot of people who are continuing to do dynamical work that don't think of themselves as doing ecological psychology. But you also have the people who think of themselves as doing ecological psychology, spend as much time learning programming calculus as they do about perception and action. So I think that the mainstream of ecological psychology, which is not the mainstream of psychology at all, are people who follow Gibson's basic ideas about the structures of the environment and the non-representational nature of perception and motor control, and try to make sense of them using dynamics. But there are a whole bunch of other people, and I mentioned some of them, Rick Dale, Michael Spivey, Alex Paxton, Drew Abney, who aren't really ecological psychologists, but are doing the dynamical approach. And we who tend to think of ourselves as ecological psychologists, let them come to the parties. We collaborate with them, and we find there's a lot of agreement, even though they are not dogmatically ecological. And this is a problem for the ecological approach into psychology, is that it's presented, especially by the people at University of Connecticut, as this like package of ideas. You have to believe all of them, or you don't, or you're not part of us. Let's go back to Heidegger for a second. You're not one of us. But I think that there's a lot of ideas in Gibson's ecological psychology that can be useful for people who don't drink the Kool-Aid, right? And I guess that I've been mentioning Dale, Paxton, Kello, Richardson. Well, Richardson has drunk the Kool-Aid, but Kello, Dale Paxton are people who are fellow travelers, right? So they take Gibson's ideas seriously, but they don't believe the very dogmatic portions of it. And by the way, I should point out that the dogmatic portions of it were not in Gibson's own work. They were in the work at University of Connecticut. And again, this is crucial scientific work to try to make Gibson's book, which, as you pointed out, doesn't read like a science book, into a scientific theory, right? So in order to do that, they said, okay, here's what information is. Here's what perception is. Here are the laws that we need to use to explain animate interaction with the environment. And there's some, I would argue, strange philosophical ideas built into their codification, formalization of Gibson's own pretty loose ideas. So I think it's natural and good that people who aren't, who don't think of themselves as University of Connecticut ecological psychologists can still find things that they can use in the ecological approach. And, in fact, I don't know, I'm heretical, right? Because I spent a year at University of Connecticut. I'm friends with all of those people who kind of made ecological psychology into a proper scientific psychology. But I disagree with them about a lot of things. And that, they tolerate me, I guess. But because they think I'm trying to help, but they don't think I'm actually helping.
I mean, like you said earlier, science is hard, and there are such little pockets of intelligibility everywhere that we ought to use every tool available to us.
Yeah, I mean, that's the phrase you just used is actually one that is brings to light my kind of pessimism about the future of science, right? I mean, I guess I think that, and this is Nancy Cartwright's idea more than anything, that if you look around the world and look at scientific practice, what you find, she puts, are little islands of intelligibility. That's the phrase you use as well, right? Little pockets of things that we can repeat in the lab over and over again and make sense of. But those little pockets of things that we can make sense of using physical laws or whatever kind of explanatory structures we bring to the table aren't the world, right? They're small portions of the world, typically in very controlled settings. And Cartwright's main point in his book from the 1980s is that you can't necessarily extrapolate from how particles behave in a gas chamber to how they behave in the room. Right. And so again, the pocket of intelligibility is this isolated set of just a few particles when, there are so many in the room with us, and they might behave very differently. But the pocket of intelligibility is what we grab onto and do our scientific research about. And we learn deep things about them, but they might not be general.
Right. And that's sort of agnostic of ontology, right? However ontology might play out, that's just a statement about, well, our epistemic limits, or how far our methods can really go.
Yeah, I mean, again, another person from the 80s, Ian Hacking, has said once, wrote somewhere, this is the 90s, I think he wrote this, that he just thinks that the world is much too rich and interesting for there to be one true theory of it, right? And I think that we have to grab onto the thing. And again, this is not critical of science at all. Right? I think this is really important work, and it's intellectually satisfying, and it helps us build cool things. But, the idea that, I'm a physicist, I understand reality as it is, and you don't, because you didn't take Calc 3. I think that's a mistake.
Right. Like a case of this might be exotic quantum mechanical explanations of consciousness, right? Like there's so many, and
No, go ahead. I mean, I guess the only thing I was going to say is I view them as exotic. And I guess this is another very controversial thing that I think is that we're not going to explain consciousness and the rest of the mind separately. Right? That is, consciousness is not like a little sparkle that gets painted on to your knowing what's around you. Right. So the idea that we need quantum mechanics to make sense of consciousness, but not cognition, not thinking, not experiencing more generally, I think that's got to be a mistake.
Right. I mean, maybe we're both wrong, and in 100 years something changes, but it certainly looks like the case right now.
Right. I mean, I'm fully confident that I'll be wrong about lots of things going forward. Right. I mean, as a scientist, as a philosopher of science, you kind of make bets on things. You say, okay, I'm interested in this because I think this is likely to teach us something valuable. But you shouldn't be betting that people will be talking about it in 250 years.
Yeah, no, fair enough. As an aside, since you mentioned it, what do you think of the current theories of consciousness?
I don't no, I don't have positive views of them. Because again, I think they all start with this assumption um, that consciousness is an extra ingredient, and we need to make sense of that extra ingredient. But I think that a theory of consciousness should be a theory of all of our thinking, experience, mind. Right? That is, we're not going to be like peel off the consciousness and make sense of that. And this is, I learned too much for my years being with Daniel Dennett, I guess. But I'm very skeptical of the idea that consciousness is this sparkle that gets added. And I also spent, I went from being an undergraduate studying with Daniel Dennett to being a PhD student alongside David Chalmers, who was several years ahead of me. But so he and I would have these conversations where my job was to say what Dennett would say to his points. And what I realized during this is that once you accept his basic premise that there's something to consciousness that isn't just knowing what the world is like, then you end up where he does as a kind of dualist. I mean, if you grant, so the key point is to not grant that assumption that there's something special and sparkly about consciousness that isn't true of remembering where you left your keys.
Right, right. Yeah, just looking at the current theories, it just doesn't feel like we even have the conceptual tools to be able to criticize them in that way.
Yeah, and I guess there's so much theory and so little data, right? And you could argue that look, we all have the data, right? We're all conscious, but I feel like you need to systematically gather data about conscious experience, and there just isn't enough of that to support the kind of theorizing that's going on out there.
No, totally fair. Okay, going back to dynamical systems theory, somewhere, I forget where, I heard you mention that you're approaching dynamical systems theory less as a modeling tool and more as a tool for data analytics. Do you mind explaining what that's about?
Sure. I don't
I
remember.
don't know if that's still something you're committed to.
I don't remember saying it. I was probably drunk. Uh, no, I don't remember saying that. But what I think is that any theory that we have of something is going to be very abstract, and we're going to need something to put it in contact with data that we gather. And dynamical systems is a way to make sense of data that we gather that at least doesn't contradict ideas from the ecological approach and the fellow travelers who also are skeptical about the kind of baseline representationalism that the cognitive sciences brought into being, reinvented in effect. So you can use dynamical systems in lots and lots of different ways. I mean, it's basically calculus, and nowadays a lot of it is the calculus that people use to make sense of living systems. So the kind of far from equilibrium, I keep saying this phrase, things that are energy sinks, things that take energy from the environment. You use that branch. Now you can use it in a kind of very theoretical way, as people like Turvey and Swenson and Turvey do, when they say, look, you can use this far from equilibrium thermodynamics to make sense of what life is and to make sense of what perception is. But you could also use it in a very concrete way. And the most famous example of that is Scott Kelso having people do this, right? he's trying to make sense of the phase relationships between their fingers. So you can be, I mean, it's a tool, right? It's math. You can use it for all kinds of different things. You can be as close to the phenomena as you wish, or as close to the theory as you wish. So I guess I'm trying to make sense of what you remember me saying and why I might have thought it. So in certain circumstances, it's much closer to the theory. In other circumstances, it's going to be just how do we account for this data? And I was about to say, how do we fit this curve? But that's not really what we're doing when we do nonlinear dynamical modeling. There are a whole bunch of assumptions built in that allow us to make predictions about things that we'll find, and then we do the experiments to see if we can find them.
Right. Okay. Shifting gears a bit. Mirror touch synesthesia. What is mirror touch synesthesia, and how did you become interested in it?
So, mirror touch synesthesia is a 21st century variety of synesthesia. It was first described in the 21st century by Banassi and Ward, I think 2006. I got interested in it because out of the blue, I got asked by an artist, Daria Martin, to write something for a book that she was doing. And there was this promise of giving a presentation at the Tate Gallery in London. And I was really excited about that. So, I don't always say yes to things that are outside my area, but like, oh, I could give a talk at the Tate. That'd be really cool. But so that's how I got interested in it. And the phenomena is itself very interesting. There are a subset of people who experience this synesthesia, in which they experience touches that are not on their bodies, so they see them as actual touches on their body. So it's synesthesia because it's visual information that they experience as touches. And there are all kinds of different versions of it, and some people only experience tapping of non-human objects as on their body. In other cases, it's only animate things, and there's a wide range. The people who have these experiences don't find them to be negative in any way. They find them as kind of enhancements. And in Daria Martin's book, there's some descriptions of the kind of erotic thrill you get watching other people kiss, right? And kind of unacceptability of even slight cartoonish violence in a television program, right? Because again, if you are experiencing this, you feel, you're watching Rocky and you see, Rocky get punched, you feel that punch on your body and it hurts. So again, so there are these differences between people who have this experience and those of us who don't. But it's not a disorder, right? It's a difference.
Right. Okay. So how did you come to model that? Or sorry, I'm trying to understand how you go from that to the idea of sensory motor empathy.
So the people who experience this kind of synesthesia describe it in very different ways. And my first thought was, oh, this is just an extreme form of empathy. And that's the way a lot of the people who experience it describe it, is that they just have more empathy than other people. And as I was trying to make sense of this and, giving a little, private, not very, small audience talk about it, my colleague Heidi Maybaum, who's an empathy expert, said straight away that what you're talking about is not empathy at all. Because empathy requires knowing that the thing is not happening to you, that it's happening to someone else. So that kind of pushed me away from thinking of it as empathy. But I also think it was a matter of knowing what it's like for other people, right? That is, so it's not empathy of the kind that you would need the theory or the simulation theory to make sense of. It's not like when a mirror touch synesthete sees Rocky get punched, they say, oh, if I were getting punched, it would hurt. Therefore, I know how the person being hurt is felt. That's not what happens. Right? So it's not this kind of cognitive process. It's this kind of embodied being with other people, I've called it. And what I think it points to, I called it sensory motor empathy. So it's the kind of way in which you are with others unreflectively and skillfully. And I guess I view it as kind of pointing toward a different way that mirror touch synesthetes describe their experiences. And they talk about there's one particular one that Daria Martin interviews, who talks about, as a child, they didn't understand that we weren't all supposed to be sharing experiences all the time. Maybe they never learned to not have other people's experiences. And I guess what I think is that we do have other people's experiences, all of us. Mirror touch synesthetes are just an extreme case. And I've been mentioning this work on social interaction by Rick Dale, Alex Paxton, Drew Abney, Chris Kello, Mike Richardson. I could keep naming names. Tehran Davis, another person, who basically demonstrate that for the time of an interaction, two people who are interacting are not really separate things. They form one thing for a while. And that one thing that they form, I would argue, is what makes you're just responding in extraordinarily subtle ways to what your partner is doing, right? You're not consciously aware of how you're doing it, you're just doing it, right? And I think that that's how we interact with others all the time. That is, we kind of form a unit with them and allow them to control our behavior, and we control their behavior. And that unit is the thing that has the properties of an individual living thing, and also is the avenue through which the rest of us, along with mirror touch synesthetes, connect to one another by knowing what it's like in a kind of loose sense of knowing what it's like for them. And again, this is Alex Paxton and Drew Abney especially have done work on what they call complexity matching. So when you are engaging in a behavior, it always exhibits a certain kind of complexity, which is a complicated mathematical idea. And again, it's related to certain ranges of the variables that measure complexity are what I was talking about earlier as indicating good health. And so as I'm doing something, my behavior has a certain level of complexity. I don't know what it is. As I'm watching you do something, your behavior has a certain level of complexity, which I don't know what it is. Like, I can't consciously access the complexity of my own behavior or the complexity of your behavior. But when we engage in healthy, helpful social interactions, we mash our complexity with our partner. So there's this kind of implicit, unconscious ways that we stick to one another to form a unit. And I think that's how mirror touch synesthesia works. And that's how we all work. As the mirror touch synesthete says, we just learn to not have those feelings. We learn to not have them consciously accessible to us because they're not linguistically accessible. I mean, to figure out the complexity of my behavior at any moment, I have to do a whole bunch of math. Right. And we don't do that. We don't do that. So I'm responding to the complexity of your behavior, even in this kind of not very rich interaction we're having via screens. I'm responding to the complexity of your behavior, even though I couldn't tell you what the complexity of your behavior is.
Right. Right. So and the key thing is that you're doing it skillfully, unreflectively, and implicitly.
That's my catchphrase for that. Yes. So again, because you know people that you can't dance with, right? Or have a conversation with, because there's something that they don't do right that doesn't align with how you want to do things. So it's skillful in that you see cases of people who can't do it, right? And some people have said this is like a matter of the autism spectrum disorder, is a specific set of people who the difference between them and typical people is that they don't engage with others in a way that in a way typical to the way the rest of us do. There's some great work from Rob Eisenhower from 20 years ago about this, about where he had backstory. Mike Richardson did these experiments showing that if you sit two people on rocking chairs and they can see each other and are talking, they will rock in sync. If you put a curtain between them, they don't rock in sync. So people tend to sync their activities with others. What Rob Eisenhower found, is that when you do make the same situation with a parent and their child, and the parent trying to read a book to their child in rocking chairs, and also so the rocking chairs are weighted, so it's really, so they want to be in sync. People on the autism spectrum tend to not sync with the person who's reading them a story. And they also tend to get into relationships, phase relationships with the other person that the rest of us just can't do. You know, it's like, it's the equivalent of like, oh yeah, they're rocking in 7/4, right? Or some weird time signature. That's really hard for most of us. But the people on the autism spectrum actually tend to get into these really difficult to maintain for the rest of us phase relationships with someone in a situation where it's been set up to make it very easy and very compelling to align your activity with them.
So I should probably have asked this earlier, but synergies are your idea of synergies is what's at play here. Yeah.
Yeah. So again, it's not my idea of synergies. It goes back to Haken, among others, Herman Haken, but it's from non-equilibrium thermodynamics. And a synergy is a collection of entities that, because of some energy gradient or something else, are required to form a unit for a while. So the example I use all the time is like when you flush the toilet, all of the water molecules behave in a very atypical way for a little while because there's a potential energy gradient. That's a synergy. A synergy is like a macro structure composed of components, all of whom are behaving in a weird, atypical way because they're part of that structure. Right? And really, organs are structure, cells are synergies, organs are synergies, animals are synergies. And work by Scott Kelso, Stephen Bressler and Scott Kelso and others, and then it's been taken up by Michael Anderson in his more recent work, have talked about engaging in cognitive tasks as requiring synergies among brain areas. So when you engage in a task of reaching for something that you see, your visual areas, your prototypical visual areas and your prototypical motor areas will temporarily enter a kind of coordination relationship until you've reached for the thing, and then that will dissipate. Just like when the potential energy gradient from the water in the tank goes away, the water stops being a whirlpool. Right. So again, this is also thought to be like the way brain areas interact are by forming synergies. And work by Michael Riley, Richardson, who I've mentioned, Kevin Shockley, and Veronica Ramanzoni published a paper 10 years ago called Interpersonal Synergies, in which they argue that groups of people form synergies, and here's a mathematical technique for identifying those synergies. That is, groups of people form units that are temporarily constrained to interact with one another in particular ways until some task is done or until some gradient is exhausted.
And the key thing here is that the important thing in the synergies are that the relations of the components are dominant, or they're the more significant thing rather than the nature of the components themselves.
That's right. The example that people always use when I talk about this is bird flocking. Right? Bird flocking doesn't occur because some bird says, hey, everybody, let's go this way, and then let's turn sharply to the right. That's not how it works, right? Any bird could be the bird at the front of a flock. You don't want to be the bird at the front of the flock because you don't get the kind of drag efficiency that you get from being behind and to the side of the other birds. But so it's not, in the situation, it's not as if we can predict the nature of the flock from the individual birds. Right? We have to look at the thing as a whole. Right? And we have to look at the interactions among the things. And the phrase that you were gesturing at is one that I use that I got from Guy Van Orden and Jay Holden and Mike Turvey, interaction dominant. And the idea is in something like a bird flock or a flushing toilet, the interactions of the components are much more relevant to making sense of the overall dynamic than the individual components themselves. So they call that an interaction dominant system. And Van Orden, Holden, and Turvey, 2003, argue that the human cognitive system is interaction dominant, in that the task constraints and the components, that kind of components of your brain and body that are involved in a psychological experiment, form a temporary coalition to complete the task. And when you get your $5 after your half an hour, you stop, that coalition ends.
And this isn't just restricted to interpersonal synergies as well, right? So could you use this as an argument for extended cognition for how you might interface with artifacts in the world?
Sure, you could. And again, the idea is that, again, just think about the synergy that I talked about from Bressler and Kelso and Mike Anderson, with your brain areas coming into sync temporarily in order for you to do a task. It could also be you and a tool you're using. And in the experiment that I described earlier with the herding of the object to the center of the monitor, in that experiment, we thought of as the interaction dominant system as being the person plus mouse plus computer plus task. And we weren't looking into the subcomponents of the person that enabled the person to participate in the task. Right. So yeah, synergies are, and this is true of dynamical explanations, dynamical modeling in general. The math doesn't care where the components that it's describing are, right? An interaction dominant system can be composed of all different kinds of disparate things.
Right. And as you point out, there's nothing spooky or magical here. There's no invocation of top-down causality. It's just normal and occurs everywhere in nature.
Yeah, it kind of is an invocation of top-down causality, or at least a strange kind of causality, strange from maybe a metaphysics point of view, because what you get is you have, hundreds of thousands of neurons that form this temporary coalition. Those neurons are the coalition, but the coalition of the neurons affects the behavior of the individuals. Right, just like the water molecules behave in really statistically unlikely ways when they're in a whirlpool, so too to these neurons when they are part of this synergy that enables you to engage in a task. So there's something that definitely stretches the understanding of causation from the kind of it's all billiard balls, right? And the way I typically put it, and I'm not alone in this, is that the macro structures constrain the activities of the microstructures that make them up. And this again sounds weird to a lot of people because it seems like emergent phenomena. There's a thing that is not something else besides the components, but it's also not exactly just the collection of components, because it itself affects the behavior of the components. And we can get into these discussions where people who are more reductionist than I am will say, well, really, that macro thing is nothing other than the components of interaction. And if we were components interacting, if we were smart enough, we could actually explain the macro behavior from the components. And I'm skeptical of that. I think that, and this is a phrase that I use all the time that I got from Gilbert Ryle. in a late paper by Gilmore, where he's trying to explain the relationship between thinking and talking. And he's basically saying, well, thinking isn't just talking to yourself, but it's not something else in addition to talking to yourself. Right? So it's like, it's not like you want to get between one thing being nothing but another thing, and one thing being something else in addition to the other things. Right? So when you have a synergy, there aren't multiple entities that is the synergy. There's just the collecting components that form a structure that that alters the behavior of the components in the collection. And actually, I think that this way that Ryle puts it is kind of how we want to explain almost everything in the cognitive sciences. Right? I mean, thinking isn't something else besides activity of your biological body, but it's not just that, right? So you want to get between thinking being nothing but brain activity and thinking being something else in addition to brain activity. And I actually think understanding the mind as a computational system does a really good job of that, getting between these two reductionist and dualist poles. Because, and I'm not endorsing the computational approach to the mind, but the idea that thinking is a kind of computational process that runs on your brain the way Zoom runs on your laptop actually makes, so Zoom isn't nothing but electrical activity, but it's not something else in addition to electrical activity. Similarly, if your thinking is a kind of computation, it's not nothing but neural activity, but it's not an extra thing either. Right? So I think that this is one of the compelling things about the kind of classical computational approach, is that it isn't really a reductionist and it isn't dualist. And I think when we talk about psychological and social phenomena, especially, we want to kind of be neither reductionist nor dualist about them.
Whenever these conversations come up, things always end up going to, okay, it's ontologically reducible, but it's methodologically not, or it's explanatorily not. Do you find that distinction to be helpful, or is that a bit of a cop out, or not saying enough about the situation?
Well, so yeah, good. So the claiming that the activity that the whirlpool is ontologically reducible to the activity of individual water molecules and the forces they exert on one another, even if we're too dumb to figure that out. That strikes me as a kind of religious idea, right? That is, I don't know how to do this, but it has to be true, right? It's a matter of like, my principle is that there's only one set of stuff, and it's whatever physicists say the stuff is. And right, so that's this kind of philosophical view, like, oh, so yeah, sure, there's only one thing, but we're just not dumb enough to figure out how it's only one thing. We're not smart enough to figure out how it's only one thing. And again, I think that that's a matter of like letting your principles color your views in a way that might not be appropriate, because we've never seen someone explain something as complicated as the whirlpool by using individual molecules. We have seen them explain it using nonlinear dynamical systems theory as a synergy that forms. So the claim that God could explain it a certain way, or super scientists could explain it in a reductionist way, is just speculation. And there's not really any good reason for speculating that way, I would argue.
Right. You just start off with monism and naturalism, and you write kind of a promissory note to say that things are principally reducible.
Yeah, exactly. That's exactly right. And I mean, I'm not a naturalist. I'm not, I mean, and even within physics, physicists, it's controversial, I suppose, but physicists talk about macro entities as having their own features. Right? When they talk about phase transitions in matter, they can do a lot of prediction and explanation of them without paying any attention to the individual molecules or atoms that make up that matter. Right? So when water goes from liquid to gas, a very complicated thing happens with tons and tons and tons of individual water molecules, and we can't explain that, but we can explain the critical point at which it goes from liquid to gas by ignoring all of those things, right? So this is, again, I think I stole this from Michael Silberstein, a philosopher of physics, who says that, look, reductionism isn't even true in physics.
Okay. Okay, this may be way out of left field, but what do you think about multiple realizability? Does this have an impact?
I think that multiple realizability seems appropriate in the cognitive sciences because we think that thinking is computation, and computer programs can be realized in all kinds of different matter and still be the same program, and being realized in all kinds of different ways and still be the same program. So, Microsoft Word is multiply realizable. If my, cat recognition is a computer program, then that potentially is also multiply realizable. But I've been influenced a lot by my colleague Tom Polger in his book with Larry Shapiro called The Multiple Realization Book. And what they argue is that, it's a matter of the kind of specificity with which you want to make the claims. So, a twisty and then pull the arms down corkscrew implements a corkscrew, realizes a corkscrew, as does just a twisty thing on a handle, right?
Waiters corkscrews and
swing arm corkscrews. Let's call them, fancy corkscrews and simple corkscrews. Both implement corkscrews. But what Shapiro and Polger point out is that when you actually get into the detail enough that a scientist would want making sense of these things, it's not so clear that they realize the same property, right? So any questions about reduction and multiple realizability have to be kind of couched in the vocabulary of the people who are doing the studies. So, people who are studying the different molecules which seem to be able to enable long-term memories to form, right? Now, are the differences between different varieties of protein kinase A, that's the only one I can remember, are the different varieties of protein kinase A in different creatures, are those relevant from the point of view of the biologist doing this? If not, it's not multiply realizable. If it is relevant, then maybe it is, right? So I guess I feel like, and again, this is Shapiro and Polger influencing me. We sit in meeting rooms together all the time, Tom and I do. So you can't make across the board claims about multiple realizability. You have to make them in terms of the specific aims of specific scientists. And when you do, it's not clear that what classically philosophers have talked about as multiple realizability actually applies to the relationship between abilities and brain areas, for example.
Right. No, in that book, I think they talk about how reduction is always pictured as a kind of clean reduction from one special science to the lower special science, but it's not always the case. You might have reduction from one special science to 2 levels below or 1 level below or something that doesn't reduce at all. So reduction is always locally specific, or not always, but often.
I mean, so at the same time, right? And again, if you are playing loose, you can say, look, of course, whirlpools are multiply realizable. Phase transitions are multiply realizable. Thoughts about cats are multiply realizable because I can have them and you can have them and our brains are different. But the Isabelle Pechard, a philosopher of science, talks a lot about what's relevant to like relevance relations. And the question that the way to put the question that Polger and Shapiro are asking are the differences between these two molecules relevant to the people who are using them to do science? And Pechard points out to me, Isabelle does, that this shows exactly why all the stuff I say about ecological psychology and extended cognition won't change what neuroscientists do because stuff outside the brain just isn't relevant to them.
So is there also a method problem in how neuroscience would work? So Bechdel and Mundell made the argument that there's this graining problem, and when you're looking in multiple realizability, you're often coarse graining the function and fine graining the realizer, and then that leads to confusion because you're not just assessing the both sides of the equation similarly.
Yeah, that's a really great paper, that Bechtel and Mundell paper. And I think, you can view what uh, Tom and Larry do as a version of that, right? It's a matter of the fineness of grain. And what they point out, Bechtel and Mundell are saying, look, as a matter of kind of ontology, we coarse grain some and fine grain others. And Poulter and Shapiro saying, as a matter of scientific methodology, some things are coarse grained and some things are fine grained. And the question is whether the coarse grained thing aligns with the fine grained thing from the point of view of the people who study the fine grained thing.
Yeah. Okay, so coming back to computational theories of mind. So when we're talking about activism, dynamical systems theory, all that, um, there's this question that comes up of synthetic systems. Can Does all this grant us evidence that you can implement cognition in synthetic systems, and then is there little significance to be placed on the biological implementation itself? Do you have any thoughts about that?
I spent a lot of time trying to understand Robert Rosen, who's a theoretical biologist who supposedly has a proof in category theory that a living thing could not be a computational system. People who understand category theory better than I do um, argue that he makes mistakes in the proof. Um, but this is the kind of center of his views, where he says, look, living things are like this. They have metabolism and functions to repair the metabolism. That's what makes a living thing. Computers are like this. In the same time frame, Maturana and Varela are inventing autopoiesis, which looks a lot like metabolism repair, Rosen's view of metabolism repair, but they're inventing it in a way that they argue shows how the properties of life can be realized computationally, how living things are kinds of machines. So these kind of two crucial figures in the sciences of complexity are very, very similar views of what makes living things living. And one of them argues that that means they can't be computers, and the other argues that that means they definitely are computers or machines. And I mean, I delved into this in a little more detail than I do most things about 15 years ago. And I guess what I came to realize is that there is nothing about metabolism repair systems, as Rosen describes them, that could not be implemented in a computer program. Right. And I have, with a former student, Tracy Turgeon, who was my undergraduate student, we built some, artificial life systems that were metabolism repair systems. We never got that published. I don't know why. We just gave up on it after a couple of rejections, I guess. But so I guess I don't think there's anything about living things that makes them impossible to make out of silicon and electricity, right? But I mean, I do think that living things are very different from toasters, right? Living things are very different from computers, because this goes like, I don't know, half an hour back to interaction dominance, right? A computer, and this is Kant, right? This is from the Third Critique. A machine that humans built is made of components organized in a particular way to serve a function that we decide when we build the machine. A living thing is a set of components that are organized the way they are so that they keep the living thing going, right? So they have their kind of own purposes. right? So there's something quite different about living things from machines. But what we've learned um, since the 1950s is that you make mistakes when you underestimate what clever programmers can make computers do. So, I think that, compared to a living thing is nothing like an iPad, but that doesn't mean you can't build a simulation one in a virtual machine on your laptop. A simulation that is, has relevantly similar properties and arguably could be called a living thing.
What would you think about like Piccinini's view here? The idea that living things are computation or neural computation is computation, but when we go down into the details of what physical computation is, neural computation turns out to be sui generis.
Yeah, so being Piccinini and I disagree fundamentally about things, but I mean, I think that there's something to the claims here, right? I mean, what Piccinini is doing is basically saying the reason that it seems hard to say that the brain is a computer and to identify the computational properties of neurons and neural systems is that we've misunderstood computation, right? And, I guess so. My sense, the way which I think he's right, is that if you change what computation means, it's pretty easy to describe brains as doing computations, neurons as doing computations. So I mean, he's a reductionist, and he's much more of a mechanist than I am. I love mechanistic explanation, but I think it's not the only kind of explanation. But I mean, I think he's right that if your goal is to argue that your brain is computing the kind of standard Turing machine computation or whatever characterization of computation you prefer, physical symbol systems won't cut it. You need a different understanding of what computation is if you want to argue that brains are engaging in computation.
Right. Where do you see the limit in mechanistic explanations?
All the stuff I've been talking about the whole time: interaction dominant systems, phase transitions, far from equilibrium systems, explaining. I mean, and if you think about it, the main point of neo-mechanistic philosophy of science is to eliminate emergent phenomenon, right? Is to say, okay, here's this macro thing. We can identify components when arranged in the right way are identical to this macro thing, right? So when I talk about far from equilibrium systems and how there's a kind of macro thing that is nothing but the micro thing, but also not something else as well, that doesn't align with the neo-mechanist thinking. So there are differences among neo-mechanists. And so I find, I also, have an office near Bob Richardson's office. He retired this year, but for years I would talk to Bob Richardson about this. And I think he and I agree that neo-mechanistic explanation is really important, but not everything is a mechanism. Not everything is subject to that kind of explanation. And over time, it seems to me that people like Bill Bechtel have changed what they mean by mechanism to make it so that everything is a mechanism. And Richardson isn't willing to do that. And, Piccinini and Craver aren't willing to even consider the reality of macro systems as non-reducible entities. So there are differences in the club. And I find that, the neo-mechanist with whom I agree most is Bob Richardson, and the original book by Bechtel and Richardson, what's so great about it is they identify this kind of explanation in biological sciences. And then they say, oh, by the way, here's where it's going to lose its grip. And later Bechtel says, well, actually, it can still get a grip in lots of those situations. And Richardson says, it loses its grip. There are genuine emergent phenomena.
Yeah, it's tricky.
It's very tricky.
I can't get my brain around the idea of how we could be non-computational.
Well, so I mean, I guess everything I've been saying suggests that at bottom we're not computational, right? I mean, that is, our engagement with the world is not best described by assuming we have states in us that stand for things in the environment and that are manipulated according to rules. Now, of course, if you're doing complex human-only things like solving puzzles, or you're going to do something akin to computation, but I don't think it's built down into the fundament, as it were, of our ways of being. Again, this is where I disagree with Piccinini and others, and most the majority of cognitive scientists are not on my side here, but that's fun.
Right. Okay. Okay. So maybe to end off, do you want to tell us a bit about what your next book is going to be like, if you want to share?
Yeah, no, I'm happy to. It's either going to be called Being With or The Intertwining. So being with is a Heidegger phrase, intertwining is a Merleau-Ponty phrase. And in the book, I basically develop a phenomenological view of what it is to be a person, and that is being necessarily embodied and embedded and social. Right? So the sociality is built right into the basic self. We're necessarily with one another, and then I try to develop a scientific case for that. And then the last part, which I'm writing now, I point out that, hey, these feminist thinkers have got to this place much more quickly than we cognitive scientists did. And if we are demonstrating that they're right about the basic sociality of being a person, then maybe they're also right about some of the political ramifications of that.
How's that been? That seems like a very exciting collaboration with feminist political philosophy.
It hasn't been a collaboration yet. It's been
Inspiration.
me learning from
Yeah.
It's been me learning from that. Yeah. And I don't claim to have that much expertise. I just, when I was an undergrad, I was a grad student, sorry, not an undergrad. I took a course on feminist political theory, and I just realized back then that, wait a minute, this is what embodied cognitive scientists are saying, right? And you're critiquing the patriarchy. We're trying to make sense of how we think, but we end up in the same place. And I've been very interested in that for a long time. And now with the recent work in social coordination dynamics, and I keep saying the same names: Rick Dale, Mike Richardson, Alex Paxton, Drew Abney, Taron Davis, Mike Riley, Veronica Ramanzoni, all these people doing this great work on social coordination dynamics, enables me finally to really write this thing I wanted to write since I was in grad school about the relationship between certain forms of cognitive science and feminist views of what it is to be a person.